All right, let's go over the questions from the checkpoint for Module 7. So first question here is to find the derivative of function, which is probably most effectively dealt with the chain rule. I think you could expand this, but that would be kind of a harrowing process. So the most direct way, let's just deal with this as the chain rule. So how do we find the derivative of compound functions? First, we take the derivative of the outside function. So maybe let's do this first. Let's be very careful about what our functions are. So let's say that h is our inner function and g is our outer function. So one way, probably the most direct way to define this, is the inner function is what's inside the bracket. So h of t is equal to 1 minus 3t to the fourth. And then g of t will be equal to basically p cubed, because whatever's inside that inner function, I'm going to raise to the third power. So f prime of t then is going to be what? It'll be equal to g prime of h of t times h prime of t. So what is the derivative of g? So the derivative of t cubed is going to be 3t squared, except I don't want the t to be t. I want the input to this function to be h of t. So 3 times what squared? 3 times 1 minus 3t to the fourth, all squared, times h prime of t. What's the derivative of h? That'll be, by power rule, negative 12t cubed. So if I clean this up a little bit, I get negative 36t cubed times 1 minus 3t to the fourth squared. Right, question 2. Derivative here, again, the most direct way to do this is going to be the chain rule. So what's our outside function this time? Outside function is going to be a trig function. So what's the derivative of cosine of something? That'll be the negative sine of something. And I'm saying generic something instead of x because we want to respect what the input to this function is, which is 6x to the fourth minus 4. And finally, you want to multiply that by the derivative of the inside function, which is going to be 24x cubed. So all told, negative 24x cubed times the sine of 6x to the fourth minus 4. All right, question 3. So solve dy dx for y equals natural log of radical x squared plus 4. So y equals the natural log. I'm going to rewrite this a little bit. Natural log of x squared plus 4 to the 1/2. This is one of those times where there's no reason that chain rule has to be limited to an inside function and an outside function. We can have, as many links in the chain, metaphorically speaking, or as many layers of this function as you want. So to kind of show you what I mean here, let's do this. Let's make our kind of like the journey of our variable x. What's the first thing that happens to x? Well, it gets put through, my first function, and I'll kind of combine some things together. So what comes out of this is x squared plus 4. Then what happens to x squared plus 4? Well, that's going to go through a square root function. And then that becomes the square root of x squared plus 4. But we're not done. There's a final thing that needs to happen, which I didn't leave enough room for. So let's do this. This is going to go through a natural log function. And what comes out of that is the natural log of whatever it came in. So x squared plus 4. So I have 3 different functions to take a derivative of. And we'll go, usually we do outer, then inner. Now we're going to go outermost, then middle, then innermost. So what's the derivative of a natural log function? That derivative is 1 over x, except we don't want 1 over x, we want 1 over the input to this function. So that was radical x squared plus 4. So that's the outermost layer of the chain rule. But now we're going to go one layer deeper. Now we're going to take a derivative of a square root function, or, x to the 1/2. Probably easier to do that because now you can use power rule to think about it. What's the derivative of x to the 1/2? That'll be 1/2 times x to the negative 1/2. But what's the something that goes in there? Well, I have to respect whatever the input was to that function. In this case, it was x squared plus 4. So x squared plus 4. And then finally, what is the derivative of our innermost function, x squared plus 4? That is simply 2x. That comes from power rule. So this is our derivative. We are done now. We did 3 different layers. Is there any way this simplifies in any kind of a nice way for us? Let's find out. So 1 over radical x squared plus 4. What is x squared plus 4 to the negative 1/2? Well, that's the same as, it's going to look weird, but I'll do 1/2 over square root of x squared plus 4. And then finally times 2x. So a few convenient things happen here. So I get the 1/2, which will cancel this 2. But I think all told, I get x over x squared plus 4. So, and like usual, I am not showing myself the multiple choices, but hopefully something in this process looks like one of your options. All right, and finally, the arc sine of 2x. So in a previous video, and I think one of the other exercises you had to do was write down this fact. I know that the derivative of arc sine x is equal to 1 over radical 1 minus x squared. So based on that fact, I can use the chain rule here. So my inner function is going to be 2x, and my outer function is going to be arc sine of x. So what is the derivative of arc sine of x? We just wrote that down. So 1 over the square root of 1 minus something squared. What is that something? That something is going to be the inner function, which in this case is 2x. But then I want to multiply that by the derivative of the inner function, which will be 2. So if we clean this up a little bit, we get 1 over, actually 2 over, the square root of 1 minus 4x squared.